Keep to the minimum blocking code such as described in the previous video. For instance, synchronous interactions with the database, CPU-intensive tasks such as transformations or traversals of some big data structures, and also sorting algorithms. Because Node is event-driven by its architecture, use async code where possible. This involves using async Node.js or third-party library APIs, promises with either async await or callbacks. Callbacks themselves should be kept as simple as possible, i.e. no side effects. This makes code easier to understand and maintain. Use streams to manipulate large buffers. Operations executed on buffers will take some compute time. In case of large files or amounts of data, using streams is going to break down those large buffers into smaller chunks and give the event loop a breather to manage other I/O operations. For sizable or frequent CPU-bound tasks, blocking operations, you want to consider some strategy to either break them into smaller chunks that are queued or offload such tasks altogether to a worker thread or maybe a child process depending on the use case. Be mindful of using timers, set immediate, set timeout, set interval, and their frequencies. In some extreme cases, they could schedule large amounts of callbacks in the timers phase of the event loop, and in the perfect storm type situation, their execution could consume considerable CPU time, thus effectively blocking the event loop. That said, in the real world, I haven't ever seen a situation where somebody would be overusing timers, but still, it's something to keep in mind.